Hello everyone and welcome to Java Basics. Today we will learn how to use a library to parse and save JSON. Don't worry if this seems alien. We will discuss JSON and what it means. We will also make the code we built up until now much simpler. This is the code from the last video, which is our starting point. Today's code is in this URL. It is the video description, so you don't need to copy it. JSON stands for JavaScript Open Notation. It's a way to represent data that we can send over the network or save to disk. Up until now, we invented the way in which we saved the files. We used commas and newlines. This works, but it's also error-prone. A small mistake can break the file. It also means that we need to write a lot of code to read and write to the file. JSON can make that simple and better looking. There are several libraries to read and write JSON files in Java, specifically Jackson, JSON, and Moshi. Of the three, Moshi is the least known, and least popular, but it's the most evolved and modern of the three. All three are very similar, so if you understand the concepts underlying one of them, you can probably pick up the other one relatively easy. This is the page where we can find Moshi on the internet. If we visit this page and scroll down, we can find this. I'll zoom in a bit so we can see. Here we can see instructions for integrating Moshi into Maven or Gradle. We can copy this and use that to change the project. I will skip the introduction of JSON itself. I'll get to it when we finally see it after we write it. Let's go right to the code, or really right to the pom.xml file. Going to the project we worked on in the last video, I opened the pom.xml file in the root of the project. Up until now, we didn't touch it, but as you may recall, the motivation to move to Maven project was the ability to add a dependency to the project. This file is an XML file. XML stands for Extensible Markup Language. It's a special type of language designed to represent information. In this case, the file represents information about how our project is structured and what it needs. A lot of what you see here is just boilerplate. It isn't important to us right now, but needs to be here. Now we need to paste the dependency we got from the web page. But since this is an empty project, it doesn't have a place to paste it. We need to create a dependencies section. XML has an opening and closing tags that you see here. The ID can complete these tags for us, just like in code. We build a hierarchy of tags which are used to include everything that we need. Every tag must be closed or things won't work as expected. Now we paste the dependency here. If there are other dependencies, they can fit in this area together. The next stage is telling IntelliJ to fetch the dependency we just added. We expand the Maven drawer by pressing the button here. You can use that same button to collapse the drawer later. By pressing the refresh button here, the project is up to date and we can start using Moshi in the code. Which brings us back to the code where we can start adding Moshi code. We want to read an object of type list that includes status objects. Moshi needs to know the type of the objects we want to read so it will know what we're looking for. For that, it needs a JSON adapter. This code I got from the Moshi page. This is code that I got from the Moshi page. Right now, I'm only declaring an adapter. Notice I declared this as a field since I would want to use that adapter also when saving the code soon. The JSON adapter class was missing and I had to use the Alt-Enter shortcut to add an import statement to the class. Next, I want to read from a file with JSON extension rather than TXT. This is just for convenience. I could avoid that change, but it looks better like this. Next, I'm adding more code from the Moshi page. To read and write JSON, we need the Moshi class. Normally in Java, we allocate an object with new. In this case, we're allocating an inner class, a class called builder, within the Moshi class. We then invoke the build method on it. This seems awkward, like awkward syntax to us to use. Why not use new Moshi instead? This lets the Moshi API add arbitrary arguments to the creation process. We aren't using any arguments here, so the benefit isn't apparent, but this is called a builder pattern, and it can be very powerful when used correctly. Next, we need the type of the object that we read from the file to initialize the list JSON adapter. Notice that Java is case sensitive, so the word type here is different from the lowercase word type next to it here. On the left, we have the class name type, and here we have the variable name. We invoke the static method new parameterized type on the types class from Moshi. This accepts the class name we need to read and write, list. It also accepts the generic type for that class, which is state. Notice that we're passing class objects. Every class in Java has an associated class object that describes it. It can tell us everything about the objects, its name, its fields, its methods, etc. We pass these types onwards, and Moshi can use them to learn how to read and write the class. Finally, we create an adapter with the given type object and assign it to list JSON adapter. We can now use the adapter to read and write state objects from JSON files. First, we need to delete the current code that reads the data from the text file, since this will no longer be necessary. We can now use the list JSON adapter to convert JSON to a list of state objects. We still need the file read API, but only to read a string, as the JSON parser will take it from there. This is much simpler than the code we had here before and surprisingly more powerful. If we decide to add additional fields to the record tomorrow, this code will work exactly the same way with no code changes. That's pretty fantastic. Before we proceed, we need to move the status list to a field. We will now need to write the entire file instead of appending. This isn't an option with JSON. That needs to be a member of the class. Next, we scroll down to the finish game method, where we need to add the new write code that would write JSON. We start by deleting the existing code except for the exit, which we will still use in the same way. I could write this in a single line of code, but I broke it to 2 lines for clarity. We first use the JSON adapter to convert the list of entries to a JSON string. The next line again uses the files API, but this time to write a string to a file instead of reading it. Since the JSON format is a string, this works nicely with this. We're almost done. There's one big obvious missing piece here. Care to guess? We need to add the last entry to the status list, so all elements will be listed there. We allocate a new status object and add it to the list. Once we do this, we can run and generate the new JSON, or at least we think we can. Let's try. Running the project, it all seems great. First word works great, second, and finally I'm giving the right answer, and damn, that's an error. We missed something. Initially, I made this mistake and thought about cutting it from the video. but it's important we all make mistakes, and this is how we learn the most. This is a pretty problematic error that would probably stump you if you ran into it. When you click on the stack frames in the exception, it's clear that the add call that I added here failed. It seems that list doesn't support add, but it does. So why the error? Control or command click can take us back to the declaration of the variable here. We can see how status is initialized, and notice there are two ways. One is when we read data from JSON. That works great. The second one is through collections.empty_list. If we look at the documentation for that method, it seems that the empty list returns an unmodifiable list, a list that can't be changed. That's why it fails when we try to change it. The solution is trivial. We can convert it to a new array list, which is a standard implementation of list. Since we're creating a new instance, it's empty and the code will work correctly. Since it's a standard list, it's unmodifiable. Running this, we can see the input works correctly and completes correctly. It works for the second run, but I won't make you watch that. Let's go directly to the generated JSON file. I formatted this file with Alt-Command-L or Alt-Control-L on a PC. This makes it more readable. You'll notice that the file looks very much like an array and object declaration. In a way, it is. The square brackets surrounding this here represent an array of objects. This maps to our list. Notice we have another list of attempts. This maps to the attempts list we have in the status record. In fact, we have entries for every field within the status object. The value maps to a string, a number, or an array. This all loads and saves seamlessly thanks to Motion. That's pretty cool. You can now understand why it's flexible. I can add a new field and it would just read it based on the new name. Very convenient. JSON is a powerful file format which we will use further as we build up this tool. Running this locally on our machine is cool, but we want to build web applications. This is what we'll do next week. We'll start working on Spring Boot and get this running in a web environment. If you have any questions, please use the comment section. Thank you.